Hi everyone, I'm pouyakhalaj.architect. In this video, I'm going to take a building facade that I found on a Pinterest and turn it a real buildable architecture model. First, I analyze the facade and retrace its real dimension in AutoCAD. Then I model the project accurately in Revit. And after that, I bring the model into a D5 render and create a realistic render. This video shows my full workflow from reference image to the 3D model and final render. If you enjoy an architectural workflow like this, don't forget to like the video and subscribe the channel. Let's get started. As the first step, we select the facade design from the Pinterest. The image is a high-end architectural render with clean and well-balanced design. The main challenge here is how to extract the real dimension from the single image. In this part, I'm going to show you a practical method that will help you a lot of future projects. For this process, we use AutoCAD. I will import the reference image into AutoCAD and use it to estimate real-world dimension. This will allow you to model the facade accurately as possible and recreate it in Revit almost exactly like the original design. Now let's open up AutoCAD. We copy the image and paste it in using Ctrl-V. Feel free to import it at any scale you like for now. It doesn't matter, because we'll fix the scaling in the next step. We'll use the X-line or line command to draw the imported line on our image. First, I draw a line for the floor level. That's the lowest part of the building. Then the second line will represent the underside of the ground floor solid. This way, we are defining the height of one story. I can draw the vertical line at this stage, which shows the building width. Now I select all the line and the image together. Then use the scale command. After running the scale command, I press R to activate the reference object because I want to set the size. Now I can specify that the distance between my horizontal line is, for example, 3.90. Is adjust my image and the length I draw to match the actual dimension. With this way, we made the shape closer to the real what. We now have a good guide for us. The real size may be different, but the shape will match overall. Now, we can find out the size of the outer parts too. Now we can figure out the rest of our measurements. For example, here we can see that the height of the outer floor is approximately 4.20. We just need to round the size a bit. And now, we are going to measure the width of the building. To start modeling in Revit, we need the floor level height and the building width. Then we'll go back and extract the necessary measurement from the photo using the same method. Now the exciting part begins, and we are heading to Revit to start modeling the project. We open a new project, and the first thing you should always do is set the unit in Revit. For project unit, press UN. I always work in meters, so I set the length and distance to meters, matching the units being used in AutoCAD. I will just set the decimal place to 2 digits. In the next step, we are going to bring all the level we got from AutoCAD into Revit. For this, we can open any elevation view. It really doesn't matter which one, as long as we can see the level. Revit already has a default floor height. So, all we need to do is match it with our first floor, which is 3.90 meters. Then we'll simply add the rest of the level based on that. To add level in Revit, we have two main methods. The first one is drawing a level manually as a line. The second method is defining the distance between the next level and the previous one. And this is the method I will always use. For this, go to the Architectural tab, select Level, and start the command. Then from the Modify panel, choose a peak. In the Offset field, you can enter the exact height you want. Once the ground floor is set to 3.90 meters, we define the next height for the upper floors. The height is 4.20 meters. And since each floor needs two levels, we enter this value directly in the offset. This way, we created all the levels we need. Now we can simply go to one of the levels and start drawing the walls. For this step, we already have the building that measured in AutoCAD. However, since we don't have the exact depth of the building, I'm going to enter it approximately for now. For the building width, since we already have the exact measurement, I'm entering 7.80 meters. For the depth, I set it to 15 meters. After drawing the perimeters walls, we need to use the floor tools to create the slab for the floors and ceiling of the units. To create the slab, all we need to do is run the floor tools. I usually use pick lines and for now select the outer edge of the walls. Then I simply confirm it and the floor slab is created. Now I'm going to remove the front wall of the building, the symbol that contains the parking entrance in the 3D view of the image. This helped me clearly identify the facade direction when working in a perspective view. At this stage, we need to define the balcony area on this floor. First, we need to determine the balcony width. To do that, we draw a vertical line from the finished edge of the balcony and measure the distance. In this case, the balcony starts approximately 5.20 meters from the right side of the facade. I'm also going to do one extra step here. I will extend the slab inward by the same thickness as the wall. So we end up with a single continuous wall all the way up to the roof, similar to what you see in the reference map. Normally, we wouldn't do this in a real project, but since this is just for visualization and the simulation, it's totally fine. I move the slab inward by the wall thickness, use a fillet to join the edge, and then delete unnecessary line. I'm setting the balcony depth 2 meters, starting from the right side, which is already offset by 5.20 meters. I remove the extra line and then confirm the sketch. Just like that, the slab for the first floor is created. I can now copy it to the other levels and repeat the same process for the remaining floor. For now, I'm keeping everything approximate. As we move forward, we'll refine the model and match it more accurately to our Pinterest reference image. Now, following the same step, we create this slab for the top floor as well. After that, if we look at the original reference image, we can see that the side walls extend higher than the roof. I know, this isn't the exact height, but for now I'm going to set it to 4.20 meters and adjust it properly later. Now let's move on to creating the windows. For the windows, I use a curtain wall, which is actually a wall type in Revit. First, I draw a wall. Then from the wall type, I select the curtain wall, and the wall easily converts into a curtain wall. I set the top constraint to L2, which means the wall starts from L1 and goes up to just below the L2 floor slab. I can then copy the same curtain wall and use it on the next level for the upper floor as well. At this stage, if we look closely at the reference image, we can see that the windows on the first floor, the floor above, the ground level are slightly set back. I moved these first floor windows about 2 meters apart, and then I copied the same setup for the next floor as well. To match the 3D model more accurately with the reference image, I create a camera view that is perfectly perpendicular to the facade. This way, I can see the elevation from the exact same angle and fine-tune the facade accordingly. Now let's move on to creating the facade wall on the top floor. It doesn't really matter where we facade design. Up to this point, we build the base of the facade, and now we can start working on the main and defining element first. Right now, I'm going to create the wall for the top floor. I'm moving this facade wall slightly inward because that's how it appears in our reference image, and I think this is the best stage to do it. At this point, it's become clear that the top floor slab also needs to pull it inward so it sits behind the wall. So we need to edit the floor and move the slab 1 meter inwards all the way to the inner edge of the wall. We just create it. To make this more accurate, I could use a pick line, but instead I'm moving this line 20 centimeters inward, matching the wall thickness. In the next step, I need to offset the wall from the side. In the next step, I need to offset the walls from the side. From the right side, I offset 20 centimeters from the facade. The wall width is 5.30 meters, so I can draw P9 using the PL command, then offset it by 5.30 meters. Based on the reference image, we can now estimate the height of this wall and the side walls which look to be around 2.10 meters. Now we want to create an empty section within this wall using the measurement from our reference image. We draw and dimension each line in AutoCAD based on this image. The middle section is 2 meters and the side selection is 1 meters, which means we need to offset 1 meters from the right before creating the opening. To do this, I double click on the wall